All right, we're going to be looking at different angle relationships in our toolkit today. So our first angle relationship is vertical, pair of vertical angles. And those are opposite angles made from two intersecting lines. And they are congruent. All right, let's read that again. Opposite angles made from two intersecting lines, and they are congruent. So now let's create a diagram for that. Okay, so we want to create two lines that intersect each other. So here we go, two lines that intersect. They can be lines, they can be segments. I'm going to go ahead and put arrows on the end here. So we're going to say two lines. And they are the angles that are opposite to each other. So I'm going to give one example in this diagram. I'm going to call this angle here X. And then I'm going to say that this angle across from it or opposite to it is angle Y. So in this diagram here, angle X and angle Y are vertical angles. Okay. The angles that I've left blank, on the top and the bottom, those are also going to be vertical, but I like to just have a diagram where I'm listing one pair of vertical angles so you can clearly see the angle relationship there. Angle X, we can also say, because they're vertical, that it's congruent. So remember, congruent is an equal sign with a little squiggly. So angle X is congruent to angle Y in this diagram. Okay, and then these two angles here on the top or bottom, those would also be vertical and congruent, but we're just labeling one pair of angles in our first diagram there. Okay. Now we're going to look at angles that are adjacent. Those are angles that are next to each other, essentially. So they are adjacent angles, are angles that share a common side and vertex. So you almost want to think of it as angles that are next to each other. They are next to each other. Angles that share a common side and vertex, they are next to each other. We worked on a lot of adjacent angles in our first unit, so we're kind of coming back to that. Now, they don't have to have a specific angle measure, so I'm just going to create an angle here. And they also don't have to be equal, so I can put a line in the middle. Remember, that's bisecting, but I'm not going to make them equal this time. So we want angles that are next to each other. So I'm going to call this angle 1 and angle 2. But we also want to label some things on this angle. Let's label this A, B, D, and C. So remember, we can name angles by 3 letters. In this case, we would have to use 3 points or 3 letters to name any of the angles, or we could use the numbers, angles 1 and 2. So in this diagram, we can say angle 1 and angle 2. That's probably the easier way to name them instead of their letters. Angles 1 and angle 2 are adjacent. Angles. Okay. Now they have a common side and a common vertex. I'm actually going to name the vertex first. Common vertex. Remember, the vertex is a single point, and it's the point that angle 1 and 2 have in common. So that would be right here. We call that point B. So I would just say common vertex is B. Now let's look at the common side. This would be the side that both of the angles share here. And when we're naming a side of an angle, we name it as a ray. That's what this side is. And we start with the endpoint B, and it goes in the direction of D. Now, what I put above that is a line with just one arrow over it. Okay, so those are a pair of adjacent angles. The next type of angles that we're going to be looking at have a specific measure that they add up to. So our complementary angles, angles that add to 90, or angles with a sum of 90. Now, 90 degrees is a very common type of angle in geometry because we might be looking at a right angle, perpendicular lines. We looked at that in our last unit when we did even rotations with 90 degrees. So we're going to have two examples. Let's do an example where the angles are next to each other first. So when we have angles that are next to each other and they add up to 90, that really needs to look like a right angle. So do the best you can to draw perpendicular lines like I have here. And we're just going to create two angles. And it can cut the angle in the middle. They would each be 45. It doesn't have to though. So I'm not going to make them necessarily equal. They're just going to be adjacent to each other. And I'm going to put a little box here in the corner of my diagram to show that, yes, these angles should be adding up to 90. So it won't always say 90, but if you have this little box here in the corner, that should indicate to you that it's 90. So I'm going to call this angle 1 and 2. This is an example of angles that add up to 90 degrees. I should be able to say that angle 1 plus angle 2 equals 90. Okay. Let's look at an example of angles that are not next to each other, so non-adjacent. So angles can still add up to 90, but they don't necessarily have to be next to each other. So I'm not even going to use my ruler for this, or my straight edge. I'm going to call this angle A, and I'm going to say that it's 43 degrees. Okay. Now, not next to it, or in terms of adjacent, doesn't have a common side, but let's just draw another angle here. And let's call this angle B. And I'm going to say that it's 47 degrees. Well, 43 plus 47 adds up to 90, so I should be able to also say that angle A plus angle B equals 90 degrees. Those are complementary. So two examples of complementary angles. Okay. Supplementary is another angle relationship that we'll see a lot. Supplementary is when angles add up to 180. So angles with a sum of 180 degrees. Okay, now we have angles that add up to 180. Here, I'm just going to show you the non-adjacent example. And then below that, I'm going to show you an example of what it looks like when they are adjacent. Okay, so angles that add up to 180. Let's just say, I'm going to draw an angle here. Let's say this angle, we'll call it angle A. It's going to be 40 degrees. Now, if I want an angle that is supplementary to that, I would need it to add up to 180. So 180 minus 40, I need to make another angle that's about 140 degrees. And I'm just guesstimating here, B, 140. So in this diagram, angle A plus angle B, they are supplementary. They add up to 180. Now, when we have angles that add up to 180, but they also are adjacent, we have a special name for that. That is called a linear pair, also known as a straight angle pair. So you will hear these two terms kind of interchangeably. Sometimes I'll say straight angle pair, sometimes I'll say linear pair. So think of the word straight angle forming a straight line, linear creating a line. So a pair of angles that creates a line. So we would say these are angles, or a pair of angles rather. Let's start with that. a pair of angles that are both adjacent and supplementary. Okay, so now we want to draw a diagram of that. So first we got to start with a straight line. I will use my straight ruler tool for this. And they don't have to be equal. If the angles are equal, they can be. They'd each be 90, obviously, but I'm just going to make them different measures here. I'll make one acute and one obtuse. And then I will label one of them as angle 1 and one of them as angle 2. Now, when you're looking at this diagram, we see that this is a pair of angles that together create a line or create a straight angle. Now, we know that they're also adjacent. This would be the common vertex. This would be the side that they share in common as well. So they are not only supplementary, adding to 180, they're also adjacent. So I can say that angle 1 in this diagram plus angle 2 equals 180. Those form a linear pair. So now that we know all of our angle relationships, we're going to go ahead and solve for the measures of some of the angles in our diagram here. Grab my calculator. So in our diagram, we're actually starting with, we have here a straight angle pair. I'd like for you to also write the name of the relationship. So let's write linear pair or straight angle pair. Either one will work for that. And we know that in this diagram, angle 1 plus angle 2 equals 180. Well, angle 2, I'm going to put 67 here. So that means angle 1 plus 67 equals 180. That means I need to subtract 67 on both sides. So 180 minus 67, that is going to give us for angle 1. I'll say measure angle 1 is equal to 113 degrees. And I'm going to add that to my diagram, 113. Okay. On to our next diagram. We have this little right angle symbol here. So that means these angles are also a right angle, or they form a right angle. These are a set of complementary angles. Complementary is when they add to 90. So angle 3 in this diagram and angle 4 add to 90 degrees. We know angle 3 is 38, so I'm going to put a 38 here for angle 3. And then all I have to do is subtract that on both sides. And then we will get the measure of angle 4. Remember, we put M in front of the angle symbol when we're looking to write out the measure for that. And so 90 minus 38 is 52 degrees. So I'm going to add 52 degrees here to the diagram. Okay. And then we have two more angle relationships. We have another pair. This is a linear pair. They are angles that are next to each other, and they create a line. It doesn't matter that we kind of have another line coming from it as well. So this is still a linear pair. But this time, instead of being specifically numeric, we have an equation that we're solving for. So angle 5 plus angle 6, we know adds up to 180. Well, angle 5 is 4x. Angle 6 is 2x minus 6, and then we'll set it equal to 180. So we're going to go ahead and combine like terms, because remember, it's on the same side of the equation. 4x and 2x, those are like terms. When they are added together or combined, we get 6x. Minus 6 equals 180. And then we're just solving for x from here. So add 6 to both sides. That gives us 6x equals 186. And then we're dividing both sides by 6. So show dividing by 6 on both sides as well. And x is equal to 31. Now we're also finding the measure for each angle. So to find the measure of angle 5, I'm going to do 4 multiplied with my x value 31. So let's see, 4 times 31 is going to give us a measure of 124. I'm going to put that onto my diagram. Okay, now we want to find the measure for angle 6. We're going to do 2 multiplied with our x value 31, and we're going to subtract 6 from that. So let's do 2 times 31, and then minus 6. That's going to give us 56. And I'm going to add that to my diagram. Now, the last thing you might want to do to make sure and check that these angles add up to 180 is if you did 124 plus 56, does that equal 180? And it does. So we know that we have solved for x properly. Okay. And in our last diagram here, we have angle 7 and angle 8. These are what we call vertical angles. They are across from each other. They're opposite. And we know that vertical angles are congruent. So we know that angle 7 is equal to angle 8. And if they're equal, we can take their equations and set them equal. So instead of angle 7, I'm going to put 2x plus 7. And then instead of angle 8, I'm going to put x plus 30. Now we can subtract an x on both sides. That will leave us with 2x minus 1x because we're trying to bring all our x's to one side. So 2x minus 1x is x. And then we're left with 30 here. Now we need to bring all our numbers to the other side so we can get x by itself. We subtract 7 on both sides, and that will give us 23. Now again, we want to plug that in to both angles. We're going to do 2 times 23 plus 7. So 2 multiplied with 23 plus 7 is going to give us 53 degrees. I'm going to add that on my diagram here. I'm going to plug it into the other one too, which is x 23 plus 30. That is 53 also. And we got the same measure for both of them. So that's a way to check because we knew that angle 7 was congruent to angle 8.